Hello, today we are diving into a unique expression involving sine functions. We are given the equation sine n theta equals summation I equals 0 to n bi sine raised to the power I theta for all real theta. And our goal is to find the values of b0 and b1. We start by setting theta equals 0 in the given equation, and this gives us the value of b0 equals 0. Using b0 equals 0, sine n theta is equal to b1 sine theta plus b2 sine square theta and so on. Now taking limit theta tends to 0 on both sides and dividing both sides by sine theta, we get limit theta tends to 0 sine n theta over sine theta equals limit theta tends to 0 b1 plus b2 sine theta and so on. Now multiplying and dividing with n theta and using the formula limit x tends to 0 of sine x divided by x equals 1, the left hand side changes to n and the right hand side is b1 plus b2 sine 0 plus b3 sine square 0 and so on. And we know that sine 0 is 0, so therefore the value of b1 is equal to n. Therefore the correct answer is option 2. If you enjoyed this challenge and found it helpful, don't forget to like, share and subscribe. Happy learning!